Well, good afternoon, everyone, and welcome to Bite-Sized Corrosion. In fact, I say welcome back. It's really wonderful that you've joined us again today. And we're really excited to kick off 2022 with a 6-session series where Neil and I will be discussing pipeline coatings. For those of you who don't know me, my name is Vanessa Sealy-Fisher, and as I've already indicated, I'm joined today by Neil Webb. Today, we'll start the series by discussing polyethylene coatings, and we'll try and answer the question, how many layers? Just remembering and looking at that picture of the truckload of pipes, it reminds me just how challenging it can be to try and figure out what a pipeline coating is. In fact, I'm quite ashamed, actually, embarrassed when I remember when I really started out in the industry many years ago now. I went to site to investigate a corrosion problem, which turned out to be a coating problem, and I was very green. And in some ways, actually, I found the whole experience quite overwhelming. I was trying to take in as much information as I could. What could have caused this problem? What were the conditions? Frantically scribbling notes everywhere. And on my return to the office, Neil, I don't know if you remember, you asked me this clanger question. So Vanessa, what was the coating? Oh my word, silence. I realized that I had no idea. So I sheepishly think I said, black. And I wondered then, like many do, how on earth can you tell the difference between these pipeline coatings?
That is a challenging question. What is the coating? And there are many different coatings available for pipelines, and having knowledge of which coating is actually applied to the pipe is really important, because it affects the pipe laying logistics, it affects the backfilling, it affects the long-term performance, it affects the cathodic protection, it affects the AC mitigation. And so the selection of a coating for a particular pipeline in terms of its environment and its service life and so on is very important. And actually, the last session of this series is going to be devoted to some of the questions that we should be asking ourselves as engineers when you're faced with a pipeline project, and that is, which coating should I be using? Which ones are suitable? Because not all coatings are suitable for all conditions.
So let's change this up a little bit and let's start thinking as a new engineer. Where do we even start?
It's a good place to start is black. The pipeline that you see in this photograph is in fact a polyethylene coated pipe. The pipe sections themselves were coated in the factory with polyethylene, and generally polyethylene is black due to the fact that it has a significant pigment content of carbon black in the makeup of the material. And polyethylene coatings in general are excellent for pipeline service because they're tough, they have high electrical resistance, they have very good chemical resistance, and they don't get damaged very easily. And so for that reason, polyethylene coatings form a large percentage of the coatings that are applied to pipelines.
You make them sound as though they're almost perfect, and we know that's not the case. Let's have a look at some of the challenges associated with the polyethylene coatings, Neil.
If you think about polyethylene, polyethylene is the material that is generally used for plastic bags. You'll see on the recycling labels either number 2 or number 3, if I remember correctly, which is low density and high density polyethylene. And have you ever tried to fix something made out of polyethylene? When I mean fix it, have you tried to glue it back together?
Yeah, nothing sticks to it. But
Absolutely.
Like plastic wrap in the kitchen.
Yeah, so if nothing sticks to polyethylene, conversely, polyethylene doesn't stick to anything else. And so when you put polyethylene onto a pipe, you are immediately faced with a challenge that how on earth do you get the polyethylene to stick to the pipe? And adhesion is one of the paramount characteristics that is important for a pipeline coating, and that is good adhesion, because we don't want corrosion to occur underneath the coating. And that brings us to the second limitation of polyethylene. Because polyethylene is so inert, it doesn't have particularly good underfilm creep resistance or inhibition of corrosion if and when the pipeline coating is damaged. In this photograph, we see a very good example of a large diameter pipeline that is coated with sintered polyethylene. In this situation, the pipe is blast cleaned to provide a rough surface, which gives you mechanical adhesion. And then the pipe is heated, and the pipe is dipped into a fluidized bed of polyethylene powder. The powder then sticks to the pipe surface, it fuses and forms a coating, which is a couple of millimeters thick, and you'll end up with this sintered polyethylene coating, which is then secured to the pipe purely by mechanical interlocking between the polyethylene and the rough surface of the pipe.
One of the challenges that I see with that is that although it's holding onto the pipe, it doesn't have any corrosion inhibition in and of itself.
That is correct, because as I said, the polyethylene itself is very inert and it doesn't interact with the moisture and oxygen. There's no, what I like to call glue factor. There's no glue factor. There's nothing that makes it stick to the underlying steel. It's just this mechanical interlocking. And I'm not saying that it doesn't work. It does work, but it does have its own shortcomings. And in order to address those shortcomings, the industry has had a number of developments. And one of the first ones that came along was, well, if we've got polyethylene, which has got good electrical and mechanical properties, how can we get it to stick to the pipe? And one of the first options then was this material, which a lot of our international viewers will recognize, and they've probably heard of the term yellow jacket coatings. And it is a trade name, granted, but it is a polyethylene external either extrusion or shrink sleeve that is put over a layer of bitumen-based adhesive, a mixture of bitumen and polymers, very much like we use in many other products for the pipeline industry. And it is used between the steel and the polyethylene because it is one of the few things that does provide you, with some adhesion, some chemical adhesion, and also it provides you with good chemical resistance or corrosion resistance on the layer underneath the polyethylene up against the steel itself.
So effectively, you've described something now that is two layers, and I suppose we could term it two-layer polyethylene.
Well, you're absolutely spot on the money there, because you will find two-layer polyethylene described in the literature and in the standards as one of the material systems that is available for pipeline coatings.
Now, the product that I and probably many of our listeners am really familiar with is 3LPE or three-layer polyethylene. And I don't recall that having any bitumen, anything in it. So let's have a look and see what's in 3LPE.
Well, the 3LPE system is the next step, if you want to call it that. We know that epoxy is one of the real workhorses of the corrosion engineer and the corrosion protection fraternity. And epoxy-coated pipelines have been used extensively overseas. In particular, we had them in South Africa for a while, but epoxy coatings also have some shortcomings. We're going to talk about epoxies on their own tomorrow. Taking the good corrosion-resistant characteristics of the epoxy and combining that with the electrical resistance and the chemical resistance and water impermeability and mechanical toughness of polyethylene has brought about the development of the 3-layer polyethylene, or 3LPE as it's known, or trilaminate is another phrase that is often used. And in this photograph, you can see that we have an FBE coated pipe, and this pipe is rotating in an application plant, and the white layer that you see over there is a hot melt adhesive, a bit like the glue gun that you use around the DIY fraternity. And then the polyethylene, the black layer at the back, is also then extruded over the top as the pipe spirals, and you get this thick polyethylene layer with an intermediate layer of adhesive and the underlying epoxy. And that then gives you your 3-layer polyethylene system, which has both the corrosion protection and the mechanical properties and the electrical properties that are desirable for a pipeline.
So in other words, we now have the perfect coating, or maybe not.
Well, I wish. So the 3-layer polyethylene comprises this layer of epoxy in between the steel and the polyethylene on the outside. But it had some issues when it first was produced, because initially the industry thought that it was only necessary to put a smidgen of epoxy onto the steel in order to provide an interface between the steel and the polyethylene. And over the years, it was discovered that this led to disbonding between the system and the steel. And the systems over the years have gradually been improved, and it is now pretty much accepted that the epoxy inner layer has to be the equivalent of a standalone epoxy system if it's going to work underneath the polyethylene. Because even though polyethylene has a very low water vapor transmission rate, it does still allow water vapor through. And if the epoxy layer underneath is not man enough for the job, we'll end up with disbondment of polyethylene, of the 3LPE system, and effectively a loose bonded sleeve. Now, it's still pretty tight around the pipe, but there may well be water underneath it. It's not a problem unless there is a defect in the coating, mechanical damage, in other words, or a failed field joint or something like that, that allows electrolyte to be transferred between the space underneath the coating and the external environment. And when that happens, then you get underfilm corrosion underneath the polyethylene. Cathodic protection can't do anything about it because of the electrical shielding properties of the polyethylene. And in fact, we have this situation that is known as cathodic shielding in that situation. But cathodic shielding and cathodic disbondment really, I think, are a subject all on their own that we'll have to talk about on another day.
In terms of getting your pipe ready for your FBE, you're going to have really critical surface preparation, cleaning, pre-treatment. Has that been improved over the years, or are we still using kind of the old original standards?
I think that there's not really a lot wrong with the old standards, except perhaps that they were not stringent enough. So you have to have typically a SA3 surface preparation grade. You have to have a good mechanical profile. In other words, angular, not rounded. It has to be clean, and it has to be particularly free of dust. And that is possibly one of the most critical aspects. And in order to achieve that, a lot of the pipe mills now use a phosphoric acid-based wash as a pre-treatment for the application of fusion bonded epoxy. And there has also been other chemical treatment, notably chromate treatment, which has been given the black flag by the environmental lobby. And it's unfortunate because a chromate treated pipe or chromate pre-treated pipe actually has absolutely outstanding corrosion resistance properties with a fusion bonded epoxy coating on it. And the industry really has to jump through hoops in order to compensate for the lack of that chromate.
Sadly, that's often the case, but all of those improvements surely have pushed up the price of 3LPE comparatively to the other coatings.
For sure, but we need to remember that the cost of the coating itself, standalone, as applied in the factory, is not the only consideration when looking at the overall financial system of costing of a project. If you have a polyethylene coated pipe, you have significant advantages in terms of the cost of pipe laying. And in this particular project, the selection of the polyethylene coating, which you can see on the pipe that is strung on the left-hand side of the trench, allowed the trenching and backfilling operations to be substantially less expensive than if you had a different coating which required a higher grade of backfilling materials, like, for example, sand padding and bedding and so on. But don't get me wrong, this pile of rocks in the front is not suitable, and that represents an area where there would have to be some due care taken. But the bulk of that trench was cut out of the soil, and pipe was just laid in the native soil, put back in without any restrictions. And that is a huge cost saving. And that, in fact, was what drove the selection of this particular project, because the pipe laying was that much less expensive given the material that was applied to the pipeline in the factory.
The other concern that engineers, we shouldn't lose sight of is the bare bits of steel that still need to be joined together when we get our field joint coating.
Yeah, well, we saw that end of a pipe a few slides back. And here's one of those pipes that's now been welded together. And you can see the epoxy toe sticking out from underneath polyethylene. And this particular joint has now been coated with a fusion bonded epoxy. It could have been a liquid epoxy. And then this in turn will get overwrapped with a further either polyethylene or perhaps a PVC or a shrink sleeve, or in the form of either an extrusion or a tape, to provide the additional mechanical and electrical protection so that the field joints are protected to the same standard as majority of the line pipe that is factory coated. And here's an example of the interface between the line pipe of the factory coated pipe coming in from outside through the wall of a valve chamber, and then the pipe in the chamber epoxy coated, and the interface in this case has been protected with an adhesive tape. And we're going to be talking about tapes in some detail in one of the later programs.
Neil, another consideration that we are now needing to take into account with our coatings is what I always talk about as the new pink on the block, which is AC interference. Let's just chat quickly about what impact AC interference has on the polyethylene coatings.
Well, the advantage of the polyethylene coatings is their extremely high electrical resistance. And this then provides the insulation between the pipe and its environment, the soil. The challenge, of course, is that electrical interference or AC interference is not necessarily conductive. In other words, it doesn't have to travel through the coating. You get what we call inductive interference, as well as capacitive interference, which actually cause very high voltages on the pipe, irrespective of the presence, or in fact, in many cases, because of the presence of this insulating layer, because it means that the pipe is insulated from earth, and the induced voltage is then able to be present in the pipeline instead of discharging through the coating because of the coating's high electrical resistance. And in this picture, we can actually, this is taken during pipeline construction phase, when the pipes are above ground. You can see the proximity of those overhead power lines. And in order to prevent the operators from being shocked whilst working with the pipes above ground, because they've obviously got to weld them into a long string, pick them up, put them in the trench and so on, these pipes are being earthed with a temporary earth connection in order to discharge, in this case, any capacitive interference. And so, being a metallurgist, I'm allowed to say it, all metallurgists have two hands. On the one hand, you have a pipeline with a good electrical characteristic and insulation, which reduces the cost of cathodic protection. On the other hand, you have a highly insulated pipeline, which is susceptible to AC interference. So the challenge then is to balance the pipeline and its coating and the characteristics of the coating against the environment that the coating is going to see. So you may well find that a coating of lower resistance may be preferable in an area where you have got a lot of AC interference. In an area with high DC stray currents, you may want to have a pipeline with good electrical insulation characteristics. And that is going to be one of the subjects that we address in some detail in the last session of the series, when there's no ways that we will be able to cover the full suite of pipeline coating selection in a 20-minute presentation. But we can certainly give you all some pointers on what to consider and what questions to ask in terms of selecting coatings for a particular project.
Neil, are there other polyethylene systems other than the fusion bonded polyethylene or the sintered polyethylene and the 2 and 3 LPEs?
Most of the other systems are based on tapes. And so there's a range of polyethylene-based tapes that are available, cold applied and hot applied, significantly used for field joints, but also for mainline wrapping. If you have a situation where you get bare pipe delivered to a site and you need to give it some additional protection, it's quite easy to apply a tape. You don't need fancy equipment in order to achieve that. And we'll be talking about tapes in some detail later on. And then for field joints in particular, which is another course all on its own, there are heat shrink sleeves available, which are wraparound, all based on polyethylene, because you can get polyethylene to shrink when you heat it. Those would be the two primary systems that are available.
Great, Neil, thank you. And I hope that everybody who's been joining us today has found some of your own questions have been clarified when we've discussed the polyethylene coatings.